Now this part is going to be average atomic mass. With average atomic mass, you're probably going to need to use a calculator. We'll get rid of these numbers over here. So let's say I have something that kind of looks like this. And again, I can have different masses with atoms. It's not against the law to have something different. So let's say I have a sulfur with a mass of, let's go 30 AMU, which is atomic mass units. That's just the mass. And let's say my abundance is 75%. So what you have to do is you have to group these numbers. You're going to have to use your mass and you're going to have to use your percent. They're all set up the same way. Sometimes they have a little more information than what you need. Let's say I have another sulfur with a mass of 35 AMU. And let's say that's at 20%. And let's say I have another sulfur that's at 32 AMU. And I have another percent of 5. That would be 100% of my whole atom because these all have to add up to a 100. Now, very simple, easy thing to do. Yeah, don't worry about getting these in decimal form. You really don't have to right now. But what you need to do with these guys is, this is a process. Every time you see an AMU and a percent, you just multiply the two numbers together. So we're going to go 30 times 75. Again, very important to have a calculator. Doesn't matter, it doesn't have to have scientific stuff on it yet because this is pretty much what it's going to do. So 2250 for that, 35 times 20, 700, and 32 times 5. And it's also very important to write this out because you want to make sure you get the correct answer. When you get all those together, we're going for a total mass, so you have to add all these guys up. So I end up with 3110 for my number. That is not your end result. The other thing you need to remember about this is all my numbers have to kind of fall in between here. And you'll notice that the higher percent is the 30, so it's going to be closer than 30 than this one. So is it going to be? Well, we have to get the last result. So my last step is just divide by 100. So we're just taking care of that at the whole end after we take care of everything else. And you'll find your average mass unit is going to be 31.1 atomic mass units per AMU. That would be your answer. And it does fall in between all these things, and it does fall closer than this one. It is useful to kind of do the checks because sometimes you'll find it doesn't. That means you did it wrong. Let's go ahead and do another one. The reason I show it this way is because sometimes when you get below 10%, there are some number problems and some people don't even pay attention to it. We're trying to get rid of that part. Let's say I have hydrogen. Let's say that 99%, I'm changing the numbers around, are a mass number of 1. And let's say I've got, again, that's my mass. Let's say I've got 0.8%, which is a mass number of 2. And let's say I got 0.2%, which is a mass number of 3. Again, we're going to use the same procedures. So 99 times 1 is 99. 0.8 times 2 is 1.6. And then this one is going to equal 0.6. And all I have to do is just add them all up. Again, your expected result is going to be extremely low, between 1 and 3. that's 101.2. Well, we know that's not going to work with these guys here because it's got to fall in between them. So just remember, last step, divide by 100. 1.012 is going to be my atomic mass unit for this one. Does it fall in between? Well, these numbers here, these are the ones I'm looking at, not the percentages. It does fall really close to 1, which is my other check. Very high percentage, very close to 1. So the higher the abundance, or the higher the percentage, the closer it goes to that that mass, which with this one is going to be very close to 1. Now let's go ahead and do one last one. Again, these are all the same procedure. It really doesn't matter what you're looking at. But again, kind of simple. Let's go with fluorine. Element number 9, but again, we're not really concerned about that. My mass is going to be 19 AMU, and let's say my percentage is going to be 55%. Again, I can just make up numbers. Makes things pretty easy for me. Let's say this one's 21%. That's going to be a 76% so far. Let's go 18 AMU, and let's put a 20%. So that's going to be 96%. My remaining is going to be 4%, because I want to make all that add up to 100% of my element. And let's go with 21 AMU. So if you remember with atomic structure, all those numbers can change. That would be my mass numbers for these guys. And then, again, same procedure. Multiply, 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 multiply. So this one will be 84. This is going to be 360. This is going to be 420. And then 19 times 55. Got to use a calculator for that part. 1,045. And what do? Add them up. Again, processes are pretty easy. You just have to practice it. So I've got 1,909. Again, you got to kind of look at these numbers because, you know, sometimes you may forget, but it's got to fall in between this one and this one. That one's way out of the ballpark. So what's my last step again? Divide by 100. 19.09 is my atomic mass unit. It does not have to match on the periodic table. Sometimes it'll come out pretty close, and sometimes it won't. You just go through the same exact procedure.